name is Patrick Noel from Viavi Solution, and today I'll be talking about our P5000i fiber microscope. Our P5000 probe is a solution in which you have a USB corded microscope that can be connected into any Viavi test instrument, either for fiber, wireless access, enterprise, or metro networks. It can also be connected into a smartphone or a laptop or PC. So what is the P5000i made of? You have the USB connector that you would connect to the device that will run the test. You have the gray plastic magnification button. Then you have a metal focus knob that will allow you to make the focus into the fiber end. And then you have the test button that will automatically provide you with a pass-fail criteria. On the front end of the microscope, you have a barrel. We have different type of barrel, smaller, longer, and different kinds. And we also have a few hundred interchangeable tips, depending on the fiber connector that you want to inspect. So if you look at the top of the page here with the barrel assembly, you have the barrel. In this case, the BAP1 is the standard barrel that comes with the microscope. But we have, like I said, longer ones and with different kind of functions. And this is simply attached to the microscope with a notch key and the key channel aligned into the microscope. And then you have a whole retaining nuts that you will screw in into the microscope. And then at the end of the barrel, you can have multiple kind of tips, either universal 2.5 millimeter, or you can have ST, FC bulkhead, LC bulkheads, UptiTip, UptiTap, or multi-fiber inspection tools. So you have a very wide variety of inspection tip that you can attach to the P5000i microscope. We also have some longer tips or different tips that would have just one connection into the microscope, so you would not put a barrel assembly first. You would just put the tip itself attached to the P5000i microscope. So if you look at the fiber connector, usually you have the housing that could be like blue or green in plastic, and then you have inside the connector, you have the ferrule that will kind of hold the fiber in place, and that ferrule can be 1.25 or 2.5 millimeter. And then you have the cladding, which is part of the fiber itself, and then you have the core that is inside the cladding. The cladding is always 125 micrometer, but the core could be 9 micrometer or 50 or 65. It is a multi-mode fiber. Now, when you look at the end face through the microscope, you would see the same sections in which in this case for a simplex fiber, the ferrule is mainly a lighter part of the image, and then it provides you the surrounding of the fiber, and then the cladding is the biggest gray part of the fiber, and then you have the core in the center of the fiber. As far as fiber connectors, you have two main types. You have the single fiber connectors, in which the connector houses only one fiber, and most of the time the ferrule is made of ceramic, so it's kind of a wider part in the image, while the fiber is darker. While if you look at the multi-fiber connector, then since it is a polymer ferrule, it's usually a kind of black plastic that is darker than the fiber, and the fiber will be a lighter gray. And then in those MTP or MPO connectors, you may have 8, 12, 16, 24, 32, 48, even 72 fiber into one connector that provides a high density connectivity. As far as inspection goes, there is an industry standard. It's a IEC 61300-3.35, and that will provide you the requirements for fiber optic connector quality. It is designed to guarantee insertion loss and return loss performance of the connector, and it is a common reference between supplier and customer, so that the guesswork is taken out of the picture, and you have an objective qualification of the status of the connector. You can buy that standard from NC or any country standard body. So we also have a white paper on it. How does the IEC characterize the fiber? It defines 4 different zones. So you have the core, which is in the center of the fiber, and you don't have any scratches or defect that can be allowed in the core. In the case here of a single mode UPC fiber. And then in the cladding, you may have some scratches as long as they're smaller than 3 microns. And then you can have a few defects that are at least smaller than 2 micrometer, or you can have up to 5 that are 2 to 5 micrometer, and you cannot get any defects that can be more than 5 microns. The C section is the section of the adhesive. So that's where the ferrule is attached to the fiber. So you don't want any glue there that has been not applied correctly and that bleed out in the connector end face. And at the end, it's what we call the contact or impact zone. So that's where the 2 connector would touch in the whole section of the fiber. So this is around 200, 250 micrometer. And then you have a laxer standard there. So you can have multiple defects as long as they're not bigger than 10 micrometers. On the bottom left, you see a picture out of a connector, and you may say, okay, is it a pass or is it a fail? You don't know for sure. While when you use the built-in capabilities of the microscope, it will take a picture, analyze it, and gives you all the defects and gives you a pass or a fail criteria. So this is pretty much how the microscope works. So you can join our next video on the P5000i with a laptop or PC connection to show you how our FiberCheck Pro software works with the P5000i. So what is the P5000i made of? You have the